Ouch! Oh, hi everybody! Welcome back for another amazing video! Yay! Woohoo! Hey guys, look, it's Stretchy! Hi, Stretchy! Oh, hi everybody! Welcome back! My name is Stretchy, and today we're going to be learning about a special kind of 3D shape known as a pyramid. But right before we get into that, let's just review what we have learned over the past videos. Remember when we talked a lot about prisms? We learned that prisms are three-dimensional shapes that have two congruent and parallel faces known as the bases. And if that's true, then the prism exists. We also talked about how we could form and name all of their nets pretty much. And only a little bit about special kinds of prisms, cylinders, that have two circular bases and a bent rectangular lateral face. Yes, I'm sorry, but I was wrong at one part. Cylinders do have a lateral face after all, so forgive me if we make mistakes. So, yeah. But the main concept of cylinders here will not be taught until Unit 6 in a certain lesson. But this is Unit 4, so we're good for a while. So don't worry, don't panic. Panicking is never what I suggest you to do. Never. Never, never, never. Never panic. So, yep. At least never panic when math helps you along the way. And a bit of geometry too. So yes, cylinders do have a lateral face. Fun fact. Really? I thought you said they didn't. Yeah, I double-checked to see if I was right, but I was wrong. So, I'm sorry. Forgive me for my mistakes and for possibly intentionally giving out false information. We don't mean to do that on this channel. We're just trying to teach you some new abstract, geometrical, and mathematical concepts. So, yep, just to let you know, cylinders do have a lateral face because it's a bent rectangle. But enough of that. Don't worry, I'll teach you about cylinders, but it will be in a different video. So, instead, on today's video, we're going to focus all about pyramids. Wait a second. What is a pyramid? That's a great question, Byron. A pyramid is a solid whose base can be any polygon and whose other faces are triangles that meet at a point. Name the shape of the base and use it to name the pyramid. Oh. The base of a pyramid can be any polygon, right? Yes. Any polygon could be the base of a pyramid, as long as it is shaped like a pyramid. So, yeah, as long as the net forming the pyramid will form and be shaped like a pyramid, then the pyramid exists. So, just like prisms, pyramids could be named according to the shapes of their base. Be careful. Remember how I said base? That's because pyramids only have one base. Prisms have two. But pyramids only have one base and another curved surface. Yeah, so called the lateral faces, which is completely connected together. They look curved. So they're not completely curved, but they do look curved. So, yep, just a little bit of math to help you here. Okay, let's get started. Let's identify this pyramid. I wonder what kind it is. Well, it's actually not as hard as you think. To figure out which kind of pyramid this is, we simply just need to name the shape of the base and use it to name the shape of the pyramid. That's it, very simple. So, let's look at the base of this pyramid. S. There is an S on each side in here, and that forms a right angle. Wait a second. These form right angles, and they look almost exactly identical to each other. 4 sides equal, 4 sides identical. both pairs of adjacent sides equal and perpendicular. Hey, we have a square base. This is the shape of a square. So the base is a square shape because 4 sides of equal length. And both pairs of adjacent sides equal and perpendicular, forming right angles. So basically, if we conclude that the base is a square, which is totally correct, then the pyramid is simply known as a square pyramid. That's it. We don't have to do any more work. That's it. That was pretty quick. That was like, I don't know, maybe only a few minutes. That's right. It takes only a couple minutes to figure out what kind of pyramid some pyramids could be if they have a polygonal base. So if they have a polygonal base, then the pyramid exists. So, yep, yes. So, this is a square pyramid because a square is a polygon, right? It has straight sides. They do not curve or intersect each other. And both pairs of adjacent sides are not only equal, but also perpendicular or forming right angles. So this is a square base, meaning that this pyramid is a square pyramid. So this is a square pyramid. Now let's check out this pyramid. Where is the base on this one? Well, the base on most pyramids is the bottom face, but when tilted could also be the right face and the front face. But it's mostly the bottom face, so don't get confused. It could only be front, back, left, or right if and only if the pyramid is viewed at a different angle. So, for instance, this one. In this case, this is not the base. Instead, this is the base. So if we look at the bottom here, there are 1, 2, 3 edges that make the base. And a shape with 3 edges, or basically sides, makes a triangle. So guess what? The shape of the base over here is a triangle. 3 sides and 3 corners, which means that we don't even have to do any more work. We don't even have to visualize the shape in order to determine what it even is. This is a triangular pyramid. Yes. This method is so easy because pyramids only have one single base. Prisms have 2 bases, but pyramids only have 1 base. So be careful on that. Again, pyramids only have 1 base, which is normally here, and they do not have 2 bases because the lateral faces that make the edges of the base actually meet at a certain point, making a tippy top peak, kind of. Think of a mountain peak. The peak is the top of the mountain, right? You can think of this as a mountain, and you could think, well, a mountain only has 1 bottom surface, right? So, yeah, it's almost identical to that of a pyramid with only 1 base. So, a mountain theoretically could be a special kind of pyramid. Yeah, because it only has 1 bottom surface. And this pyramid only has 1 bottom surface, which is the base. So, yeah, visualizing mountains can really help you to understand that pyramids do not have 2 bases. Because if it did, then climbing up the mountain would be easy. Because you would be able to not trip over this point and finally get some room to rest. But this meets at a certain point, so it looks triangular the more you go up. So, yeah. And if you trace a line, it appears to be a triangle over here. And surprisingly, a pentagon over here. There's a lot of different things you could do with pyramids. That's very cool. But how about this pyramid? Well, again, like I said, the base is the bottom, but could also be the left, right, front, or back if and only if the pyramid is viewed at a different angle. I think it's viewed at a different angle because if we look here, the triangular lateral faces which meet at the point meet at a different point, which means that they are viewed at a different angle. They meet at the same exact point, like theoretically over here, but this time they are just rotated sideways so that the point that they are facing and making together is at a completely different location. So, yeah. But what about this pyramid? What is the name of this pyramid? Well, if we count the number of sides, there are 1, 2, 3, 4, 5, 6. Let's double check. 1, 2, 3, 4, 5, 6. Yes, there are 6 sides as the base. So the base is shaped like a hexagon because it has 6 sides and 6 corners. Or 6 angles. Angles and corners are identical. They could be known as angles or corners. So, yeah. Which means that we don't, again, have to do all the work in order to recognize this shape. This is a hexagonal pyramid because, as you could see here, it has a base with 6 sides, which is hexagonal. So guess what? This is a hexagonal pyramid. A hexagonal pyramid is a pyramid with one 6-sided base, or a hexagonal base. So, yeah. And what about this one? That looks kind of familiar. It almost looks like a stop sign. Wait a second. The shape of the stop sign is an octagon. And if we double check, there are 1, 2, 3, 4, 5, 6, 7, 8. Let's double check again. There is 1. Hold on. Sorry. 1, 2, 3, 4, 5, 6, 7, 8. Yes. So, yeah. There are 8 sides. 1, 2, 3, 4. And 1, 2, 3, 4. 1, 2, 3, 4 plus 5, 6, 7, 8. So yes, there are 8 sides, which means that the base is shaped like an octagon or stop sign. Even some windows are shaped like octagons, really. So, yeah. Which means that this pyramid is octagonal. So guess what? The name of this pyramid is an octagonal pyramid because it has one 8-sided base or one octagonal base or one base that is shaped like an octagon. So yeah, this is an octagonal pyramid because it has one octagonal base. Pyramids could also be named according to the shapes of their one and only base. Kind of like how prisms could be named according to the shapes of their bases. Yeah. And what about this pyramid? Well, let's work together. I think that this is the base. This point is at a different location, so yes, the pyramid is viewed at a different angle, which means that this is not the base, but rather this is the base. So, yeah. Let's count the number of sides, everybody. There are 1, 2, 3, 4, 5. I feel so alive. That rhymes. Okay. Let's double check again. There are 1, 2, 3, 4, 5. Yes. The base has 5 sides, which means that the shape of the base is a pentagon, which also means that the pyramid is a pentagonal pyramid. See? That's very easy. How long did that take me? Like, less than a minute. I don't know, maybe less than 1 to 2 minutes. So yeah, it doesn't take very long to identify pyramids. But their nets we're going to talk about later. Anyway, we are actually coming to that very soon. So, this is a pentagonal pyramid because it has one 5-sided base, because if we double check, there are 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. A 5-sided base. There are 5 sides on the base, which is a pentagon. So that's why that this pyramid is a pentagonal pyramid. And the last pyramid should be a rectangular pyramid. Whew. That took me even shorter to solve because I immediately saw the base. And I immediately knew, okay, 2 long sides, 2 short sides, 4 right angles, it's a rectangle. Rectangle as a base, rectangular pyramid. Wow. Identifying pyramids in general could take a very quick amount of time. It doesn't take a lot of time to identify pyramids in general because although pyramids may be 3D shapes, and 3D shapes are very difficult to view, especially for beginners, if you know about the existence of pyramids, then you might be able to identify them not for very long. So it doesn't take long to identify a pyramid. I could tell you, identifying pyramids are super peasy, easy lemon squeezy. So yes, this means that the base, which is over here, is shaped like a rectangle because it has 1, 2 long sides and 1, 2 short sides. 1, 2, 3, 4. That adds up to 4. So this must be a rectangular pyramid because it has 1 rectangular base. Yes. So, let's get to their nets. You still remember what a net is, right? We learned that from right when we introduced prisms. Nets are any 2D representation of a 3D shape with faces. So, only if the 3D shape has faces could the net of such a shape be represented. So, for example, if a 3D shape does not have faces, like a sphere, it is mathematically impossible to determine how the net of a sphere is shaped like, because a sphere has no faces. So, because a sphere has no faces, we can't make a net for a sphere because it has no faces. Its one and only surface is completely curved and round. We'll talk about spheres in another video. But, anyways, enough about that. Naming their pyramid nets is also really quite simple, except with pyramids. So, yeah. Let's see. Having a hard time remembering how many sides the base has? Well, guys, the amount of sides that the base has is actually 1 edge from each triangular lateral face. So we could count all these triangles and add them up. So there is 1. Then next comes 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yes, there are 6 triangles, which means that the base has 6 sides. This is a hexagonal pyramid. Yes, we're getting the hang of this now. But hang on, because the net can only be named by the name of the pyramid. So, if this is a hexagonal pyramid, we could conclude that this is not a pyramid, but rather the net of the pyramid. So this is basically a hexagonal pyramid net. Ah, yes. Every time you name any net of a 3D shape, the name will always end in net. Like octagonal pyramid net, it ends in net. So rectangular prism net, square prism net, cube net. See? When you name nets, the name will end in net. So, yeah. The name of the net contains the name of the 3D shape that is formed by the net, and then the word net immediately after it. So, yeah. This is a hexagonal pyramid net, and this is a hexagonal pyramid. Now, how about this one? Well, I could see here that there are 2 short sides and 2 long sides that the base contains. This means that it's a rectangle. Ah, no more work has to be done. This is a rectangular pyramid. Remember, it's viewed at a different angle because the point at which they meet is sideways instead of the top. So it is rotated. So if the point that the triangles meet by is not at the top, then the pyramid either has 2 hypotheses, which I like to share. Number 1, the pyramid does not exist, or number 2, more specifically, the pyramid is tilted at a specific angle to view at different views. So yeah, this is still a pyramid because it has only one base and triangular lateral faces, except it's just from another view. So yeah, that's why it's to the left instead of to the top. So this is a rectangular pyramid. So this means that this must be a rectangular pyramid net. And if you can't remember whether it's a rectangular or a square pyramid, there's a very easy method I like to use. So, edges or sides of certain triangles are of certain lengths, right? Well, technically, this edge is longer, which means that this is the edge of a bigger triangle. So guess what? This triangle and this triangle are not the same. They have different side lengths. So guess what? This means that both of the edges of the rectangular base, or rather its sides, are also not equal in length. This means that this is a rectangular pyramid net. Yes, this is a rectangular pyramid. And this is a rectangular pyramid net. Oh my. It looks like we kind of have what I like to call a duel. Or 2 of something. How can we solve these? Well, these pyramid nets both have triangles as their bases. But what else do you notice? What strange and unusual pattern do you see in both of these pyramid nets? Wait a second. There's something different about the lateral faces. These lateral faces only have 1 tick mark in each side. But these lateral faces have 2 ticks on 2 of its sides, but 1 tick on 1 of its sides. Wait a second. The triangular prism nets must have specific names because the triangular base is a specific size, making the triangular lateral faces form a specific shape. That's right. They are the same shape. They are both triangles, but they appear differently in shape, as in deforming. So, normal, deform. So yeah, this is deforming, when a shape changes its shape. So, yeah, a shape has shape. Just like how we all have shape. Body shape. Yeah, shapes kind of have that kind of shape too. And they could deform into many different kinds of shapes. So, yeah. What do you notice about this triangular pyramid net? Wait a second. These tick marks indicate that all the triangles are of equal lengths. And plus, if we double check over here, the lateral faces, together with the base, appear to make one large triangle. And the base appears to fit perfectly inside this triangle. This makes the 3 triangles equal to each other and the base equal to itself. All of the faces are equal. This is an equilateral triangular pyramid net. That's right, because all of the faces have not only 3 sides, but also all 3 sides of the same length. So this is an equilateral pyramid net, or I'm sorry, equilateral triangular pyramid net, which means that an equilateral triangular pyramid exists, because as we could see here, one of the equilateral triangles is the base, which is at the bottom, and the other 3 lateral faces are also equilateral, which means that they are also equal in a sense. So, yeah, pretty cool once you imagine it or get the hang of it. So, yes, this is a triangular pyramid, but not just any triangular pyramid. Since all of its faces are of equal length, this could also be an equilateral triangular pyramid, which means that we could classify this one by its ticks as well. Let's check out the 2 ticks on these triangles. Wait a second. Only those 2 ticks could signal that only these 2 sides on each triangle are of equal lengths. But there is also 1 tick that signals that each of this side of each of the lateral faces has a different length than the other 2. So yeah, this side is shorter than the other 2 sides. But the 2 sides are both of equal lengths. And that, my friends, makes an isosceles triangle. Do not get confused by the base, though, because it is not an equilateral pyramid net. Because although the base is an equilateral triangle, on some rare occasions, pyramids could also and have to be named according to their lateral faces as well. So we pretty much need to look at all the faces to see if the pyramid truly exists or if it's just the net of a made-up shape. So I think the pyramid exists. Let's see if we're right. So this is an isosceles triangle, which means that both of these must be isosceles triangles, making only the base equilateral. Well, guys, 3 is greater than 1, so isosceles pretty much wins the contest. So guess what? This is not any ordinary triangular pyramid. This is an isosceles triangular pyramid. That's right, because although the base is equilateral, the 3 triangular lateral faces are isosceles triangles, because 2 of the edges of each lateral face are equal, and the last edge is shorter than the 2 edges. So basically saying, these 2 sides are of equal lengths, but this side is shorter than these 2, but these 2 are both equal. So this is an isosceles pyramid. This is an isosceles triangular pyramid net. So far, we have a hexagonal pyramid net, a rectangular pyramid net, an equilateral triangular pyramid net, and an isosceles triangular pyramid net, and an equilateral triangular pyramid, a hexagonal pyramid, a rectangular pyramid, and an isosceles triangular pyramid. So, yeah, that leaves one more pyramid, which the base appears to have all 4 sides the same length because they are marked by these ticks. Well, guys, this is not exactly accurate because the triangles are actually of different lengths. But if you look over here, in a sense, not in a complete sense, this is only in an approximate sense, because we could say that this is a square with all 4 sides of equal length. This means that although the triangles don't have to be equilateral, in this case, they could be. So the lateral faces could be equilateral. And the base is also equilateral because all squares are equilateral. they can never be classified as irregular. So, fun fact, squares are the only polygons that are always regular and never irregular. So, they are the only true regular polygons. In other words, they're the only polygons that no matter how much you turn them or deform them, they are never going to be irregular. They are always regular polygons. So, fun fact for you, this means that this is a square pyramid net. And that is a square pyramid. So, we are pretty much done over here. Wow. We learned a lot today about pyramids and their nets. Okay, so far, hexagonal pyramid net. So, let's review all the pyramids and their nets. This is a hexagonal pyramid net. This is a rectangular pyramid net. This is an equilateral triangular pyramid net. This is an isosceles triangular pyramid net. This is a square pyramid net. This is a square pyramid. This is an equilateral triangular pyramid. This is a hexagonal pyramid. This is a rectangular pyramid. And this is an isosceles triangular pyramid. So, yeah, all the pyramids could be right here. And this is a square pyramid. This is a triangular pyramid. This is a hexagonal pyramid. This is an octagonal pyramid. This is a pentagonal pyramid. And this is a rectangular pyramid. So, yeah, we learned all about pyramids. Like, do you remember the Great Pyramids of Egypt, where they actually build pyramids? They're kind of like their homes. And if you've ever been to Egypt, you have seen these pyramids. Or if you've never been there, then that's fine. You would have at least heard of Egypt and those great pyramids. Only, they are not shaped like this. They are rather shaped, surprisingly, like a square pyramid instead of a triangular one. Yes, pyramids may have had a square or rectangular base in Egypt to be built with, and then all the other triangular lateral faces could be built from there. An excellent example of an Egyptian pyramid that was built for many, many years is the Great Pyramid of Giza. Giza, I like that pyramid. It's yellow, it's dusty. Usually, almost every pyramid is, but some could be brown, kind of. Although I can't see any brown ones. So, yeah, what could I tell you more about Egypt? But, hey, at least we learned about pyramids today. So, yeah. And, believe it or not, just like how prisms could have 7-sided bases, 9-sided bases, and 10-sided bases, pyramids could also have a 7-sided, 9-sided, and 10-sided base too. Because if and only if all of the triangular lateral faces connect all the edges of the polygon together, and if all the lateral faces meet at a certain point, then the pyramid exists. So, we could say that a pyramid could theoretically also have one 7-sided base, in which case that pyramid would be known as a heptagonal pyramid, or a pyramid with one 7-sided base, which means that its net is a heptagonal pyramid net, or a pyramid net with a 7-sided base. This also means that a pyramid with a 9-sided base could also exist, such as an enneagonal pyramid, or a pyramid with one 9-sided base, or one base as a nonagon. So, yes, one base as a regular nonagon makes an enneagonal pyramid, which means that its net is an enneagonal pyramid net, or a pyramid net with one 9-sided base. Which means that there could also be a pyramid with one 10-sided base, or a decagon. A decagonal pyramid. Wow, that's very, very large. A decagonal pyramid is a pyramid with one 10-sided base, or one decagon as its base. This means that its net must be a decagonal pyramid net, because it's a pyramid net with one decagon, or one 10-sided base. So yeah, pyramids could have one 3-sided, 4-sided, 5-sided, 6-sided, 7-sided, 8-sided, 9-sided, 10-sided, and even more sided bases. The further we keep going, the more sides the base will have, and the more sides the base will have, the more lateral faces that the pyramid will have, and all of the infinite families of pyramids will continue to exist forever. Because there are technically polygons with more than 10 sides. Some polygons have 20 sides, and some even have 50, but we are not going to talk about these. You will learn about multi-shaped polygons, or pretty much polygons with 10 sides and more, in 9th grade, usually in the junior high grades and the high school grades. So, yes, in junior high and high school, both of them, you will learn about polygons that have more than 10 sides, that have 11 sides, 12 sides, 13 sides, and how these could make new different kinds of prisms, or pyramids, or any other 3D shape. Who knows? Maybe another shape could be discovered. I don't think another shape could be discovered. I mean, we already have all the shapes ready. But you do realize that you are only one part of the world's greatest future. So, make it happen. Education could make it happen. So come on, make the world shine bright with your positive energy, and continue to do well in your classes. Alright, that is it from us today. I hope you enjoyed about all different kinds of pyramids and their different kinds of nets. Oh, and one more thing. Do you know how that prism we just talked about, the cylinder, could have 2 circular bases? Well, a pyramid could also have a circular base, and such a pyramid is known as a cone. Like, have you ever heard of an ice cream cone, or a traffic cone, or a party hat? Yeah, those are all cones. Wait a minute, but you told me that pyramids could only have polygonal bases. Yes, Byron, but in the case of a cone, it is still a pyramid, because a cone, though it naively violates the description of a pyramid because a circle is not a polygon, it could be defined as a pyramid with a circular base, because a cone has more than one surface, and all pyramids have more than one surface, technically. The only 3D shape I have heard of with only one surface is the sphere. So, yeah. So pyramids have more than one surface, and a cone has 2 surfaces. So as long as a 3D triangular-like shape has 2 or more surfaces, then it could exist as a pyramid, or cone, because a cone is a special kind of pyramid, with a bent lateral face and only one circular base. So, yeah, just like cylinders or special kinds of prisms with 2 circular bases, pyramids, such as surprisingly known as cones. Cones could also have a circular base, because although cones naively violate the description of a pyramid, the circle is not a polygon, and that is true. But cones could be thought of as special kinds of pyramids, with a circular base and a bent lateral face. So it's the exact same thing for a prism. Most prisms must have polygonal bases, just like how a pyramid must have a polygonal base. But the only exceptions are the cylinder and the cone, whose bases, that are shaped like circles, are not polygons, but could still be prisms and pyramids, because all that matters is For a prism, if any prism has 3 or more surfaces, then the prism itself exists. And if any pyramid has 2 or more surfaces, then the pyramid exists. So, yeah, cones are pretty much special kinds of pyramids. And just like cylinders, which we just learned, have lateral faces, cones could also have a lateral face, because as we just learned a couple seconds ago, cones have 2 surfaces. So one surface being the base and the other surface being the bent lateral face. The lateral face of a cone is not actually a triangle in some sense. Well, it could be a triangle, but it could also be, shockingly, another different shape, which you may or may not know. It's called a semicircle. What? So you're saying that a cone's lateral face could not only be formed by a triangle, but also with a semicircle? That's right. If you bend the semicircle in the right or correct direction, then it should leave you with a cone-like structure with room for one circular base to fit in there, making a cone. Wow! Well, you learn something new every day. Yes, you do. So, anyways, yes, cylinders are special kinds of prisms with 3 surfaces. 2 of the surfaces being the 2 bases, and the last surface being the bent rectangular lateral face. And cones are a special kind of pyramid that only have 2 surfaces, one surface being the circular base, and the other surface being the bent triangular or semicircular lateral face. So, yeah, but in the sense that we agreed to, that all pyramids must have triangular lateral faces, there is a possibility that the lateral face of a cone is technically definitely formed by the bending of a triangle. It's a lot more complicated than that because it involves some shape bending. But we're not going to do that too often because, as we know, the nets of cylinders and cones are completely different than the nets of all other prisms and pyramids. So, yeah, at least we got to name all different kinds of pyramids, including cones, and their nets. So the net of a cone is pretty much a cone net. Yes. So it could be thought of as a right circular cone net because not only is the cone circular, but it also has a right angle because its radius of the base and the height of the inside are perpendicular and form invisible right angles. So, yeah, that's pretty much it. So, yeah, I hope you enjoyed a lot about pyramids and a little more about prisms, kind of, and how pyramids could be named according to the shapes of their base as well, just like how prisms could be named according to the shapes of their bases. Bye, everybody! Bye!